All right, this video is going to be about finding the roots by factoring. So we're going to be looking at higher order polynomials, and that's going to be polynomials where the exponent is greater than 2. Now, sometimes we're going to run into some quadratics where the exponent is, the highest exponent is 2, but for the most part, we're going to focus on the higher ordered ones. So we're going to find the roots, and what that means is we're going to find what is x when f of x is 0. Now, I made you a chart that kind of shows you how to think through these. So the first question you're going to ask yourself is, how many terms are in the function that I'm looking at? So if we go back over here, there are 3 terms because we have 2x cubed minus 5x squared minus 3x. So on the chart, we're going to go to 3 terms. Then we're going to ask, what's the degree of the function? Here, the degree is 3. So we're going to look at the 3 plus because the highest exponent is 3. And what we're going to be doing is looking for the greatest common factor to begin with. And this, in fact, is the example I used on the chart. So here we have a degree 3 polynomial, and we're looking for a greatest common factor between these 3 terms. And the greatest common factor is going to be x. So I'm going to factor out an x. And I'm left with 2x squared minus 5x minus 3. And I'm going to set that equal to 0. Now the question becomes, in the parentheses now, I have a quadratic, and I can factor this further. Now the number in front of x squared here is not 1, and these are not perfect squares on the ends, and there is no common factor other than 1 here. So I can use the AC method to factor this further. So I'm going to do, again, we're just factoring what's inside the parentheses. So 2 times negative 3 is negative 6. And I got to ask myself what multiplies to negative 6 adds to negative 5. And that would be negative 6 and 1. And so we're going to rewrite this middle term using negative 6 and 1. So I'll go over here, 2x squared plus 1x, so I'll just write x, minus 6x minus 3. And then we're just going to factor by grouping just like we've been doing. So I'm going to group the first 2 terms and the last 2 terms, and then I'm going to factor out the greatest common factor. So the greatest common factor between these 2 terms is x, and I'm left with 2x plus 1. I'm going to bring my sign down, and then here the greatest common factor is 3. So if I'm factoring out a negative 3, I'm left with 2x plus 1. And then we're going to use the distributive property to combine what's outside the parentheses, x minus 3 and 2x plus 1. And then the last thing is, don't forget about this x on the outside. So I'm going to put that in front to have my completely factored expression. All right, now I need to solve for x, because finding the roots is finding out what is x when f of x is 0. So I'm going to apply the zero product property and set each term here equal to 0. So x equals 0, that's my first term. X minus 3 equals 0, that's this term. And 2x plus 1 equals 0, that's this term. And now I'm just going to solve for x, so that's one of my answers, x equals 0. Here I just need to add 3 to both sides, so x equals 3. And here 2x equals negative 1, and then divide by 2 on both sides, x equals negative 1/2. So I have 3 roots here. X is equal to 0, 3, and negative 1/2. Let's look at a similar one, but it's going to go a little bit differently. So if we go down here and look at number 10, we have a similar situation where we have a 3-term polynomial where the degree is 3. So we're going to use the same strategy. We're going to look for a greatest common factor, which, just like the other one, the greatest common factor here is x. So let's factor out an x. And we're left with x squared minus 6x plus 6 equals 0. Okay, so I have this quadratic that's in the parentheses. And I would be asking myself, because the number in front of x squared is 1, is there anything that multiplies to 6 and adds to negative 6? So that would be a combination of 6 and 1, or negative 6 and 1, or 1 and negative 1 and 6, or 3 and 2. None of these are going to give us negative 6. So we cannot factor this using rational numbers. When that's the case, you have to use the quadratic formula. Now here's what I'll tell you. If you ever get in a situation where you're trying to factor a quadratic here and it's just, you can't figure it out, the quadratic formula will work every time. So we're going to apply the zero product property. So I'm going to take this first term and set it equal to 0. And so that's one of our roots, x equals 0. And we're going to take the second term, set it equal to 0. And here's where we're going to use the quadratic formula. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Again, my advice is if you ever get stuck trying to factor one of these quadratics, the quadratic formula works every time. So just if you don't know what to do, use the quadratic formula here. Here, a is equal to 1, b is equal to negative 6, c is equal to positive 6. So we'll plug this all in. X equals opposite of b. So because b is negative 6, we're going to put positive 6 plus or minus the square root of b squared. Remember, put it in parentheses. Minus 4ac all over, the whole thing is over, 2a. I'm going to calculate what's under the square root. So we'll do negative 6 squared. Remember, it's really important to put that negative 6 in parentheses. Minus 4ac. And we get 12. So we'll write this as 6 plus or minus square root of 12 all over 2. Now we have to simplify the square root of 12. I've shown you a trick on your calculator to make that really easy. If you go to your y equals and you do 12 over x squared, and then you go to your table, so second graph, what we're looking for is a pair of whole numbers where the number in this blue column is as close to 1 as possible. So we're left with 2 times the square root of 3. So I'm going to write this as 6 plus or minus 2 times the square root of 3 all over 2. And then this can simplify even further. So the greatest common factor between all the numbers outside of the radical is 2. So we're going to just divide everything by 2. And that leaves us with 3 plus or minus the square root of 3, because these both become 1. So it would be 1 times the square root of 3 over 1, so we don't even need to write that. These are our other two answers. Remember, this represents two numbers, 3 plus the square root of 3, 3 minus the square root of 3. Okay, next we're going to look at number 6. There's a couple of different ways we can do this, but I'm going to show you how we would do this looking at the chart. Remember, we're trying to find the roots, and so our equation needs to be set equal to 0. So in that case, what we need to do is subtract 12 from both sides, and we're left with 3x cubed plus 12x squared minus 3x minus 12. If we look at our chart, this is a higher order polynomial with 4 terms. So if I go to how many terms? 4 plus. And if the degree is 3 or more, which it is, Then we're going to look for a greatest common factor and factor by grouping. So if I go back here, is there a greatest common factor between these four terms? The answer is yes, it's 3. So we're going to factor out a 3. And we're left with x cubed plus 4x squared minus x minus 4. Now what we're going to do is we're going to factor this term inside the parentheses using grouping. Just don't forget about adding this 3 back at the end. So I'm going to go up here and I'm going to write the term inside the parentheses. And what we're going to do is group the first two terms and group the last two terms. So the greatest common factor between the first two terms, just like using the AC method, is going to be x squared. And we're left with x plus 4. I'm going to bring down the sign. And the only common factor between x and 4 is going to be 1. So we'll factor out a 1. But in this case, because there's a minus in front, we're going to factor out a negative 1. So negative x divided by negative 1 leaves us with x. Negative 4 divided by negative 1 is 4. Last step. Take what's outside the parentheses and put it together. Take what's inside the parentheses and multiply it. And then don't forget that this 3 has to come over. Now, are we done factoring? In this case, no. Now I have two terms here in parentheses, and each of these has two terms. So I have to ask myself, is this a difference of perfect squares? And the answer is yes. X squared is a perfect square and 1 is a perfect square. So we can factor that even further. And we're left with x plus 1, x minus 1, and x plus 4. And then don't forget, these are all equal to 0. So now our last step is going to be set each of these terms equal to 0 and solve for x. So x plus 1 equals 0, x minus 1 equals 0, and x plus 4 equals 0. And so our answers are x equals negative 1, x equals 1, and x equals negative 4. Those are going to be my 3 answers. Now, what if you forget that this is difference of perfect squares? You can still take these two terms and set them equal to 0, and you'll get the same answer. So if I have x squared minus 1 equals 0, we would still have x plus 4 equals 0, so you're still going to get x equals negative 4, but I can add 1 to both sides, and I get x squared equals 1. And then I can take the square root of both sides, and I'm left with x equals plus or minus the square root of 1, which is equal to plus or minus 1. So you're going to get the same answer. Factoring all the way just kind of flushes it all out for you. Let's look at another type. So here I have x to the 4th minus 12x squared equals 64. Now I'm trying to find the roots, and so I need my equation to equal 0. So I'm going to subtract 64 from both sides, and I'm left with x to the 4th minus 12x squared minus 64 equals 0. So if we go to our chart, because if we're not entirely sure what to do, we have 3 terms and a degree 4 polynomial. So if I go to my chart and I look at how many terms, I have 3, and my degree is 4. It's possible that I'm in quadratic form. Quadratic form is when we have ax to the 4th plus bx squared plus c. So if I have an x to the 4th and an x squared and then just a number with no variable, I'm in quadratic form. So let's take a look. X to the 4th, x squared, and just a number. So this actually is a quadratic. It just looks a little bit different than what we've been seeing. And so you can factor this, and I'm going to show you using the U substitution method. You don't have to use this method if you kind of see what's going on already. I just wanted to introduce you to the idea. So what I'm going to do is I'm going to say, let U equal x squared. And the reason I'm going to do this is because x to the fourth is equal to x squared squared. So that means x to the fourth in this case is going to be equal to u squared. So I'm going to rewrite this as, I'll do it down here, u squared minus 12u minus 64 equals 0. Now I just have a quadratic. U squared is the same as x squared for all we care when we're factoring. So because there's no number in front of u squared, I just need to find out what multiplies to negative 64 and adds to negative 12. In that case, it's negative 16 and positive 4. Negative 16 times 4 is negative 64. Negative 16 plus 4 is negative 12. So we can factor this as u minus 16 and u minus 4. Sorry, u plus 4. Now this is important. I'm not done because u is equal to x squared. So I have to take x squared now and replace u with x squared. So that gives me x squared minus 16 and x squared plus 4. And that's equal to 0. Okay, so now I have inside the parentheses two terms. So I have to ask myself, do I have a difference of perfect squares? And the answer is right here, yes. Here, no. This is not a difference of perfect squares because I'm adding, but I can factor this out further. So this gives me x plus 4, x minus 4, and x squared plus 4 equals 0. Now I can use my zero product property and say x plus 4 equals 0, x minus 4 equals 0, and x squared plus 4 equals 0. These two are really quick to solve. X equals negative 4, x equals positive 4. Here, I'm going to have x squared equals negative 4. I'm going to take the square root of both sides. And I'm going to get x is equal to the square root of negative 4. So we have to simplify this. We can't have the square root of a negative. That's going to equal square root of negative 1 times the square root of 4. Square root of 4 is 2. Square root of negative 1 is I, and we're left with plus or minus. So our answers are x equals negative 4, x equals 4, and x equals plus or minus 2i. Last example we're going to look at in this video is right here. So we have 125x cubed plus 216. So here we have two terms, and one of the terms has an x cubed. So if we go to our chart, how many terms? 2. What's the degree? 3. We might have a sum or difference of perfect cubes. So that would look like some sort of perfect cube plus another perfect cube. We go back to our problem. We have 125x cubed. We know x cubed is a perfect cube. If you're not sure if these two are perfect cubes, you can test this. If you take the cubed root of these terms, you should get a whole number. You can do that on your calculator by going to Math 4 and then put in 125. So the cubed root of 125 is 5. We can do the same thing with 216. We get 6. So those are both perfect cubes. So here we have a sum of perfect cubes. All right, the way we're going to do this is we're going to define a as the cubed root of the first term. So the cubed root of 125x cubed is just going to be 5x. Cubed root of 125 is 5. Cubed root of x cubed is x. And b, we're going to call the cubed root of the second term. So cubed root of 216 is 6. Now, a difference of perfect, or sorry, this is a sum of perfect cubes. So this is a cubed here plus b cubed. And the way that this works is the sum of perfect cubes factors into a plus b times a squared minus ab plus b squared. So I defined a as 5x, and I defined b as 6. So the first thing we're going to do is just plug in a and b right here. So a plus b is 5x plus 6 times a squared. So over here I'll do this, 5x squared. Remember, we have to distribute this exponent to every term inside the parentheses. Gives me 25x squared plus a times b, so 5x times 6 is 30x, plus b squared, 6 squared is 36. And that's all equal to 0. Now, with these sum and difference of perfect cubes, you're going to get a quadratic here. I haven't found a case yet where one of these quadratics is, we can factor it with rational numbers. And so we're just going to use the quadratic formula to solve that. So we're going to use zero product property and say 5x plus 6 equals 0. Here I'm going to subtract 6 on both sides. I'm left with 5x equals negative 6. So x is equal to negative 6 over 5. And then we're going to take 25x squared plus 30x. I'm sorry, this should be a minus 30x. Plus 36 equals 0. And we're going to plug this into the quadratic formula. So a is 25, b is negative 30, c is 36. So x is equal to opposite of b, so that's going to end up being plus 30, plus or minus the square root of b squared minus 4ac all over 2 times a. So that's going to give us 30 plus or minus. Let's go to our calculator and do this. So it's negative 30 minus 4ac. All right, I typed this in wrong. It's negative 30 squared minus 4ac. And I get negative 2700. So it's 30 plus or minus square root of negative 2700 all over 50. Now we have to simplify the square root of negative 2700. I'll move down here to do that. So square root of negative 2700 equals square root of negative 1 times the square root of 2700. And I showed you that calculator trick. So if we go over here and do 2700 divided by x squared, go to our table. What we're looking at is for a pair of whole numbers where the number in the y1 column is as close to 1 as possible. So we'll keep going and see how far we can go. That's probably going to be it. So 30 times the square root of 3. So we have 30. This gives us I times the square root of 3. So x is equal to, I'll erase this so you don't get confused, 30 plus or minus 30I square root of 3 over 50. Common factor between all of these terms is 10. So we're going to divide all the terms outside of the radical by 10, and that's going to give us 3 plus or minus 3I square root of 3 over 5. So that's going to be our other set of answers. So that's the sum and difference of perfect cubes is going to give you a lot of work here, but you should get at a maximum 3 answers.